Oh, thank you. And thanks, everyone, for sticking around after that lovely break. We're supercharging information extraction with Vision LLMs. Well, that's the title that I got from ChatGPT to make it sound interesting. It was great that we had a nice conversation in the panel around LLMs. And I think this was a great use case to talk about where you can actually safely use LLMs if you do set up a strong evaluation framework. So the first question is, what is information extraction? I'll start off with the journey that we'll take together. We'll start off with, what is information extraction? I'll then walk you through around how the solution has evolved over time and what are the different approaches that you can take for solving this problem. We'll then have an overview of how Vision LLMs work. And then Elaine will walk us through a case study on how you could implement something like this. We'll particularly talk about claim automation, and then we'll also go through some of the insights and key takeaways. So the first question is, what is information extraction, and why do we need to care about it? Well, information extraction, that sounds like a fancy word, but essentially it's taking some unstructured data and getting the relevant information out from this unstructured data. So it could be an invoice, it could be essentially like any sort of unstructured, be it like files or receipts or some business domain-specific documents. How can we really extract relevant information from these sort of documents? Now, why do we need to really care about trying to automate some of this process or speed up some of this process? The first is, again, increased efficiency. So we really want to think of how you can reduce manual data entry and how you can automate some of these key fields from images or documents. The next one is cost savings. Again, if you're able to automate this to a degree, then you can lower operational costs and also decrease the amount of extensive manual work required. The next one is scale. So in order to be able to do this at scale, there's organizations that have abundance of data available and they can't really leverage and get insights from this until they actually process this. So it really helps with the growing data needs. And then lastly is also customer experience. So think of rather than us requiring a customer to essentially fill all the given details in a form, how about they just take a picture, it pre-populates all the relevant information required, and they just verify that and get done with the process. So it really helps going beyond operational efficiency to also customer experience. So I'll talk about how the technical solution has evolved over time. This is not a new problem. This is pretty much a very common problem across the industry. And the first approach that you can think of is using converting the documents into text. So the first step is OCR, which is, again, very common, where you can essentially extract information, not just the text, but you could use tools such as AWS TextRact. Again, like each cloud provider has their own flavor of these tools, but the idea is that you extract text, which will include tables and other forms of data as well, and then you apply some sort of regular expression. So I'm sure each one of us have used regular expressions in the past. So you could apply some regular expressions, try and extract some key information, and then add some business logic around that extracted field. Now, most of us who have used regular expressions know that once you start using regular expressions, you will not just have one problem, but two problems. So the problem with regular expressions, difficult to generalize and maintain. You always come back with someone in the team being like, oh, it's not working. I need to add this additional scenario as well. So it doesn't really scale with like complex workflows, difficult to generalize, and also something that's low accuracy for different type of documents. So what's the next part? The next thing to do is try and use machine learning. So with machine learning, rather than trying to train your own model, Because it's such a common industry problem, entity recognition, there's quite a few APIs that are available, pre-trained models that can help you extract these relevant entities. An example is the AWS Textract Analyze Expense. Again, like you'd find this equivalent API across the different cloud providers. I'm just taking AWS as an example because that's what we used on some of these projects. The benefit of this approach is, one, that you don't need ML expertise. It's a pre-trained API. So here you can see there's an example of a receipt, and it can pretty much extract like things like vendor name, vendor address, receipt, date. The drawback with this is that it's limited to predefined fields. So you could only get things like, okay, person names, organizations, events. So you can't really tailor a lot of the business domain specific data. And I think this point was raised previously as well. A lot of these models are trained on US-based documents, so it doesn't work as well on New Zealand-based documents, things that might be very specific to Australia-New Zealand region. And then lastly, when you do have these predefined fields, then you need some sort of logic to be able to map this into your business fields. So what's the next option? The next option is you train a custom model on your own. So what's involved in training a model like this? You start off with labeling a document like this. So you need to label each of the field that you want to extract, and not just label what's the value for the field, but actually you'll need to label these sort of boxes around where exactly does this entity occur in the document. Now, this is quite a laborious process. You then, once you've annotated these documents, train a model, and then ingest new data, documents, and get results from those documents. This was the benefit of this approach is you can get high accuracy on domain-specific documents. Again, because it's such a common limitation with the pre-trained APIs, a lot of the cloud providers do provide the capability to customize their models with your own data. The drawback is it still requires you need to still label around 100 to 1,000 documents. And it is a black box approach. You could essentially build your own model if you do have the ML data science capability within your squad. But again, it's a time-consuming process. 12 months ago, I would say this was the state of the art. I work at Mantel Group as a consultancy. I worked on quite a few projects where we were doing this in the past. And this was the state of art. Like, you get the best solution using this approach. However, now we have something that has led us to try a different approach. How many of you have used Claude, ChatGPT with images? Tried chucking in some images, getting some questions with images? Awesome. So now when you talk about multimodal LLMs, I'll be mainly focusing on LLMs that work with images and text. So essentially what you can do is you can take this image and you can put it in the LLM and say, okay, extract the fields that I require from this image. Well, I tried to do that, and luckily I pretty much got all the fields correct. So yeah, that was all. That's all you need to do. That's the talk. But no, it's not as simple as that. It's not as simple as that. And Elaine will go through a bit more detail around how you can actually build a solution and what are the nuances that we need to take into account when dealing with such a problem. The benefit of this approach, I think the biggest benefit is you don't require to do a lot of labeling. So you don't need to label the boxes anymore. And it is fair. It is something that is very easy to spin up. It can scale really well and across a different variety of documents, and there's no custom model training. There's a big con here around the black box approach. Again, as the industry is evolving at a rapid pace in the large language model space, at this point we don't have as many tools in terms of explainability, but hopefully that would change as we go along. This is a common question that gets asked, okay, is this approach actually more expensive? Well, this is a comparison on AWS. And you can see these methods that I talked about, the expense API and building a custom model, it's far more expensive as compared to actually using a Vision LLM. So it's not just a tool that's faster to, like not just an approach that you can implement more quickly, but it's also more effective, cost effective, and you can achieve good accuracy as well. So the next topic is how Vision LLMs work. Well, I'm sure, once we get into this, we'll pretty much miss our after party. So I won't take too long. I'll probably give you a brief overview so that everyone has a basic intuition on how these models are actually working. Now, there's a few key concepts. The first one is embeddings. How many of you have heard the word embeddings? I'm sure. Awesome. So embeddings is just a fancy word to convert text into numbers. So as we know, machines and language models understand to understand words, they need to convert the words into numbers. Now, if I have this question of where would you place this apple out of these 4 clusters, what will be the answer? I hear C. So that's because you can see that this is a group of fruits. So that's essentially what we want to do. We want to convert the numbers rather than just converting the words into some random numbers. We want to be able to convert and represent each word in a way that it makes sense from a semantic representation. So all the words that are similar should appear close together. And this is in a 2-dimensional space. The next key concept is tokenization, which basically is how do we break these large text into smaller chunks. So one example, it's a very simplified example here, but we can basically break that sentence into individual words. Now, the third idea is if you talk about just words, now words do have position in them, right? So if I take 2 sentences with the same words, dogs chase cats, cats chase dogs, they don't mean the same thing. So what is important is the position. So what you'll need to take into account when you're representing these words as vectors is also the position. So there's this idea of positional encoding in there as well. And lastly, there's the attention mechanism. So if you think of the word bank, that it can mean 2 things. It could mean the bank of the river or money in the bank. I always think of the second one. But what's important is that when you hear the word bank in that sentence, how you're getting the context is based on the neighboring words. So in this sentence, the context is coming from money, whereas in that the context is coming from river. So that's the attention mechanism where you need to understand the word context. And that's pretty much it. So this is what's part of the transformer model, which everyone knows is the building block for all the large language models that we have today. So essentially, what a transformer model is, it basically takes an input, does tokenization, and converts those and generates embeddings, takes the position into account, and then you have these blocks of attention. And what we are essentially training these models to do is try and predict the next word. So if you take in an input as write a story, then the response is once, and then you go on generating each token or each word as is. So you basically just tries to generate the next word based on the previous context that we have so far. Awesome. So last piece of the puzzle, because we're talking about Vision LLMs, how do we connect images to text? So this concept comes from the CLIP architecture. Again, OpenAI came up with this CLIP architecture, which is again the building foundations for some of these vision text models, where essentially if you think about images, at the end of the day, images are also just numbers, right? It is pixels in an image. So what you do is you convert the image into, again, some sort of numeric representation, and you convert the text into a numeric representation as well. And then the question is, how do you combine them, or how do you learn this sort of representation together? So what you can essentially do is you can basically take a text data set. So essentially what we can do is we can take heaps of images, and then we can take a text to try and learn what this representation is. We can basically say, okay, we'll take heaps of these dog images, and then we'll try and train a model that can learn to identify whether this photo is a dog, is a plane, or is a car. So essentially what it will do is it would take the text that you're providing with this sentence, and it will take the image and try and learn how to associate these two things together. And that's essentially the building block to be able to learn the connection between the images and text. Awesome. So hopefully that gave you some insights on how these models work. And to give a more practical example, I'll pass it on to Elaine.
Thanks for the introduction, Sahil. So yeah, to give a more practical lens on what we're talking about, we're going to look at this case study, which is a claims automation. So the client that we're looking at is a large insurance provider, and they have implemented some sort of document automation or OCR solution in various parts of the business, but what we'd seen at the moment is that had varying levels of accuracy, as well as that kind of overhead costs of doing all that training. Every time you want to extend to a new business unit or type of document, you need to do that labeling effort, and also the solution ends up costing a lot if you want to use those custom models or even the Analyze Expense API. So yeah, at the moment, the solutions don't scale across the business, and they're finding it a bit difficult to maintain it and generalize that across new corpuses of documents. So what they were looking for here is an event-driven solution. So a document comes into the document service that triggers the event for the intelligent document processing solution to happen. It extracts the fields and writes it back to the location where they're expecting those fields. So just as a light example, expanding on what Sahil had said before, this is an example of a carpet invoice. So maybe insurance companies here receiving this, there's been some carpet damage, and we're just asking it to extract all the fields that are there that are relevant to us. I'll go more into what is involved in that prompt later on, but you can see it extracts things pretty well. Should have prepared a live demo, but this is a here's what I prepared earlier kind of thing. And you can see that it does pretty well at interpreting everything. It gets most things right. And even just a simpler example, something like a cafe receipt, you don't even have to define what fields go in. You can just tell it to extract fields, and it can make some sort of good guess at it. But specifically in the way that we've been implementing it, this is the prompt that we have. So we have a bit of the problem definition. So just tell it what we're trying to achieve. So here's an invoice. We want to extract fields in a structured way. And we provided 3 extra pieces of information that are dynamic. So it can be updated by whoever's owning the solution moving forward. So the first piece of information that we're providing is the field descriptions. So see here, for example, the first one we have is customer email. So we tell it what the name of the field is, a description of the field. Here we're trying to feed it as much information as possible. I'm sure if you've used ChatGPT or anything, you can realize that it can get some part of the way there, but the more like context you can give it, the more specific you can get specific information you can provide, it can do a lot better. As well as the type, and then providing examples tends to help as well. The second piece that we're adding in is the actual OCR extracted text. So we've done a few experiments of pretty much just chucking everything in one prompt and trying to get the LLM to do it, a combination of trying different models to do the OCR step and then providing that as an additional argument as part of the prompt, and that tends to be what works best. So here we have a step beforehand where we're asking a different model to get the raw text, and we feed that in as part of this prompt just to help it be able to more easily identify and map what text goes to which field. The last one is an output structure example. So we're showing it another example just for it to be able to understand a bit better what the output we're expecting is. And the way that we've implemented it here with feeding it in, having kind of the problem definition be fixed, but feeding in the fields and extra information this way is you can update the fields quite easily. You can add in more fields. So if the business is saying, we actually also want this additional field, all they need to do is provide us with the metadata, some examples, and you can add it in really easily. Or if you want to change the schema or anything else like that. And there's some additional information at the end of this prompt. So we're saying here, don't include any other content except for the JSON object itself. Because if you've tried some of the models, you'll see that if you ask for a structured output, like a JSON object or something, it tends to be have some preamble of, hey, here's the information you requested, and then the information, and then the actual thing that you wanted, which is cool, but it's not very helpful when you're trying to automate that process and get the data out straight away into the next system. And yeah, how do we actually determine the accuracy of the solution? So what I really like about this is that, well, for two things. First is that this is currently, like in some parts of the business, still a manual process. So there are people actually manually entering these labels. So there already is a set of ground truth that we can label against. Yeah, and also that it's easy to compare. So we can say, compare against the ground truth and say, like, is the extracted invoice number the same as the one that's been manually labeled, yes or no? Whereas if you're trying to measure accuracy for something like a chatbot or something, yeah, complicated like that, more free text, then you have to have a more sophisticated solution than just matching and saying whether it's right or not. So we get the extracted OCR text and the fields, and then we compare it against the ground truth, and then we're able to say whether it's right or not. And the way that we kind of we iteratively work on improving performance is that you can try it yourself. You can get pretty far of the way from anywhere from like 60 to 85% of accuracy just from that simple prompt like that, without providing no few shot examples, no fine tuning of the prompt itself. You can get pretty far, but depending on what accuracy level you're wanting to get to, you'll make it an iterative process where you're improving the prompt, or maybe you're adding more pre-processing steps to the document before you get there, or post-processing steps for formatting, or specific data validation rules that you want to provide. So yeah, we compare the output against the ground truth, and we get the accuracy level, and then we can also look at the errors that are produced, and we do this is a bit of the manual process. We look at where these errors are, why the LLM might have made that kind of conclusion. Is it something we can fix in the prompt, or is it something that's like, okay, that's kind of fair, I could see why the LLM would do that, maybe it's a post-processing step instead. And I think, this process can go for longer, depending on what level of accuracy you want, and how long you want to spend on it. But there's kind of a point of diminishing returns where you're putting in like a week's worth of effort and it's only going up by 1 or 2%. So it's something to work with, I guess, depending on your timeline and stakeholders. And just a note on the performance of the model. So I've got a graph for Claude 3 Sonnet against the Textract custom query as well as the Expense API. But the main thing I want to focus on here is 3 of the key metrics that we look at for accuracy. So we have individual field accuracy, which is easy to measure. It's just for invoice number, how often are we getting it right? What's the percentage? The overall field accuracy is the same. So across all the fields, how often are we getting it right across any of the fields? And the last one is perfect document accuracy, which is out of all the documents, how many of the documents, what percentage of them have all fields extracted correctly? And wanted to give some key insights and takeaways from doing this kind of solution for different customers, as well as just generally doing LLMs anywhere from proof of concept to production for the past while, just to give some insights so you don't have to go through the same pain that we do sometimes. The first point that we have here is use case suitability. So it's all good to go and I guess accept that the project that's defined will be what you're going to undertake, but it's really important to sit with the business and understand that what the problem actually is, what they're expecting from it, and whether it's actually the right technological approach to the solution. So yeah, do they actually know what they want? I don't want us to be businessy, but does it have business value? If we don't want to build it and then just have no one use it, or no one know how to use it, or just not be applicable. As well as a question of, does it actually need to be generative AI? I know everyone just wants to solve everything with that at the moment, but sometimes that ends up being more complicated and not a good investment anyway. So it's good to pose a question of, can it be a more classical machine learning approach instead? Or even just a simple automation sometimes. And along with this, the business readiness. So besides just the actual, the very specific thing that we're looking at, so just OCR, the accuracy of that, we need to make sure that it actually fits in with the overall way that the business uses this data. So we need to engage SMEs as early on as possible to make sure that we also map to any ref data we need, or data integrity checks or business rules that need to be applied later on, because we want to build an end-to-end solution, not kind of just sit in the corner, say that, oh, this works really well, we have really high accuracy, but then it actually doesn't work overall if we're not considering all the other moving parts of the system. And then make sure that there's a plan for continuous improvement and ownership moving forward, because especially for us as consultants, we're going in and building something, but we want to make sure that it actually is going to be something that's used long term, and the business has the skills and capability to actually take that on and keep working on it, because it's not likely that you'll get it right the first time. Another important point is benchmarking. So Here, we want to make sure that we know what the metrics are that we're working against when we start a project. So whether that be the ones that I talked about before, so maybe we're saying that we don't care so much about some fields like invoice number because that might be specific to whoever's producing the invoice, but we really, really want to make sure that we have things like the total cost or the date and all the line items captured. So we want to, if that's important to us, we want to outline that as a specific metric that's important to us. Or maybe if we're only confident in doing automation of the system, if we get a certain level of perfect document accuracy. It's good to highlight that early, and besides just the accuracy part, there's also considerations for cost and latency. We need to make sure that it works for the people that will be taking it on later on. And making sure that you have a gold standard data set that you keep comparing against, and that this is representative of the data that you expect overall. So this is especially relevant if you're kind of toying with different models, or you want to test that the model doesn't degrade over time, considerations like that. Another point here is building compound AI systems. So I think when we engage with the business and they get really excited about the results, then they say, oh, okay, cool. How about we also add a classification step? And if it's this type of document, we also want to extract these fields. Or maybe if it's this type of other document, we don't care about these other fields. And also if we want to say that all the subtotals should add up to the total, or maybe more business rules that might be applied. It's actually very difficult and not in our best interest to put this all into one prompt, and it's really important to try and separate these pieces into different parts so you can track how each part is performing, you can log that, and you can make improvements where you need to for each of those little components instead of trying to bundle everything together, and then because it's a black box as well, you don't know where it's gone wrong or why it's made this decision. And it'll definitely help in the long run, and it'll be a lot easier to maintain and monitor moving forward. And the last point I have here is LLM ops considerations. So it's not enough to do just DevOps or even just ML ops now. Every time you take on a Gen AI project and you take it into production, you also have to think of the continuous improvement, training and ownership of the LLM-based solution, I guess. And you need to make sure to build the human feedback loop in pretty much from the start as a consideration. So you're not going to get it right the first time, and especially if in these processes where we're trying to empower a manual process, we need to make sure it works for them. If it's something that's customer facing, we want to be continually testing it, getting feedback from our customers to make sure that it works for them. And with that, we'll finish off. Thank you so much. It's been great to chat with everyone today, and let's keep the conversation going. We'll be around the rest of the day, or here's our LinkedIn as well.